All right, so we should have everybody here. I don't know where people are. They're moving slow today. All right, we are going to get started. So a couple of things, you guys. The tests from yesterday and Monday, hopefully you saw your grade in School Tool. If you did not, of course, you can check that out. All right, but we'll get those back later in the week. Overall, they were pretty good. I was pretty happy with the results, so I hope you felt good about your grade. Otherwise, we have one last little detail with trigonometry, and that is in our packet. If for any reason, if your packet is not next to you, take your notes on a separate piece of paper because you're going to need them. All right, so let's get going into that. I'm going to switch my camera here. All right. So let me zoom in a little bit so you guys can see. So law of sines, it's actually a really kind of a cool concept because all of the trig that we've done so far is all based around right triangles. Law of sines allows us to work outside of that because you don't need it to be a right triangle to make it work. Okay? So what we're looking at for today is day 1. So when you flip right on over into page 1 here, you've got yourself a triangle. What I want to do with the triangles, I want to label a couple things. So the first thing, capital A, capital B, capital C. That's when we're talking about the angles. So like at the corners here, or the angle measures themselves. So like A, B, and C. I then want to label the sides opposite A, B, and C using the little lowercase, which I sometimes lovingly refer to as baby A, B, and C. This is going to represent the side lengths. Turn on that light there. So across from angle A, this would be little side A. Across from B, this is little lowercase b. Across from C, that's little lowercase c there. So it's just literally across from the angle of the same letter. All right, what the law of sines reads as, it's got 3 parts when we use any 2 at a given time. It says that the sine of angle A over the length of little baby a there is equal to the sine of angle B over little b, which would also be equivalent to sine of capital C and then over the length of side C. So those are all proportionate. So what we can do is we can use this to solve for missing sides and angles. So I'm going to say sides slash angles of non-right triangles. So it'll still work for right triangles, but the nice thing is it doesn't have to be a right triangle. And up to this point, it had to be because to be able to use it, we needed a hypotenuse and so on. In this case, you don't need a hypotenuse. So it works really nicely. All right, for the very first one, when we read through it, saying in triangle ABC, they're giving us some measures. Don't stress about it being drawn to scale. Give yourself a triangle, label the A, B, and C, and then label any measures you're being given. So I'm going to slide my paper on up, so I hope everybody's got that written down. And when it says triangle ABC, I'm not going to fib. I draw my triangles the same every time. I don't overthink it. All right, saying angle A is 18 degrees. Angle B is 74 degrees. Little a is 17, so that's the side across from angle A, so that's 17 over here. And it's asking us to find the length of side B. So we want this side across. So we could leave it B. I'm going to throw an X there just because I kind of like seeing it that way. And so how we use the law of sines is I only want to create a proportion. I don't want all 3 parts of it. So in this case, the parts I would need are the parts that I have. Angle A and little a, so let's label that little a, and then angle B, and I want little b over here. So the proportion that I'm going to use is the sine of capital A is to little old baby a, as the sine of angle B is to little old side B. All right, let's plug in the stuff that we know. So if we plug in, this will be the sine of 18 degrees over little a, 17. And then think about what goes in over here. Sine of angle B, so that's going to be sine of 74 degrees. And then over plain old x. So first step is to plug in those values. And then from here, easiest thing to me when I'm seeing a proportion, cross multiply this guy. So when we do that, if I multiply here, this is going to give me x times the sine of 18 degrees. And then here, I'm going to keep this exact for right now. 17 and then times sine of 74 degrees. I really don't want to have some crazy decimal that I got to write down, so I'm just going to leave it exact until I get x all by itself. So to get x completely alone, divide now by that sine of 18 so that that part would cancel out. And now I'm going to the calculator with that whole darn expression. Right. If you have the alpha y equals on your calculator, sometimes it feels nice to put it in a fraction that looks just like what we have. So I have it on my calculator. I feel like most of your calculators probably have it. Try to get out of the glare there. So if I go alpha y equals and hit that n over d, then I can type in 17 and then times sine of 74, close it up, and then sine of 18. And let me double check that, yep, I am in degree mode, so then I can just hit enter. Now, if you don't have the n over d, you guys can literally type it in as just 17 sine 74, and then just go divided by sine 18. It will work just fine. All right, but sometimes you just feel better having it match exactly how it looks. So that's it. You set it up, you cross multiply to solve. Once you get x completely alone, throw it in the calculator, and then this one says round to the nearest whole number. So x should come out to be 53. And since it was a side length, if there was a unit of measure like inches or something, you could label it. We weren't given a unit of measure here, so we just stop and say 53 here. And now when you think about it, mine is completely not drawn to scale, but the biggest side is supposed to be across from the biggest angle, right? So the fact that, I don't know if that's the biggest angle, but it's a heck of a lot bigger than this. So the side across from it should be a heck of a lot bigger than the side across from the 18 degrees. Any questions on the first part? All right, cool. So flip it on over. We're going to skip around a little bit since we only have 20 minutes to work together today. So I actually want to skip down to question 4 on the next page. So what I would like you guys to do is draw it first, label what you're given, and then we'll talk about what to do. All right, so hopefully you're a step ahead of me. I'm just going to label mine the same as last time, A, B, and C. Angle B this time is 46 degrees. Angle C, I've got 27 degrees. And then side A. So remember, side A is across from angle A. So that's my little a there. That would be 28. And it's asking us for the side B. So across from angle B, this is where my x is going to go. When you look at a question like this, what we have to remember is for you to be able to set this up correctly, I need the angle and I need the side opposite. So when you look at this, I have angle B and I'm looking for the side opposite. So I want to use B. I have angle C and I have side A. So that's not a matching pair. To have a matching pair, I need the side opposite and the angle that goes with it. So in this particular case, I have enough info to at least find angle A. That's what I really need to do first. So I need to find angle A first by just using the idea that the angles in the triangle, they're all adding up to 180. So just do a little work off to the side. If I go, 46 and 27, you're either mental mathing it or you own a calculator. So that gave me 73. And then if I go 180 minus 73, oops, just kidding. There we go. That'll leave us with 107. So if I give you two sides of a triangle, you don't really know what the third one is. But if I give you two angles of a triangle, you can absolutely calculate the third one. So use that to your advantage. So now I've got angle A and I've got side A. So if those are the two parts that I have, those are the two pieces of the law signs I'm going to use. So it's going to look a little bit like the last one we did. So when I think of sine of capital A over baby A equaling sine of capital B over baby B, now plug in the stuff you've got. So sine of 107 over 28. The other piece of it is going to be sine of 46. And then what we're looking for, you can either call lowercase b or you can call x. B looks a little bit too much like 6 sometimes, so I pick the x there. All right, give it a try. Cross multiply, divide. We'll compare answers in a moment. All right, if I have any brave souls that completed it and are willing to throw their answer in the chat, to the nearest whole number, what are we coming out with there? Good, I got one person with 21, another person. Awesome, because that's exactly, you guys, what you should be coming up with. So when we set it up, cross multiply and divide, this is the expression going into the calculator. And so then if I bring mine up here, I'll zoom in just a little bit so you can see it. 28 times sine of 46, and then over sine of 107 should be coming out just a bit over 21. So to the nearest whole number, 21 flat is what we're looking at. All right. Does anybody have any questions on the steps so far? No, we're good. All right. When you flip on over to number 5, a little bit different. So flip on to the next page. Number 5 at the top. I want you to start just like we did the last one. Just draw yourself a picture, label what you know. All right, so if you take a look, the nice thing is you've got angle A and little baby A. They're looking for angle B, you've got little b. So that part's easy. You've got the matching parts. The difference this time is we're looking for an angle. So in the end, if we're looking for an angle, this is code for we're going to need to be able to use the inverse trig function, or in this case, use inverse sine. All right, so you might want to write yourself a little note about that. But let's plug in. So we're going sine of angle A, so that's 42 degrees, over the side opposite, so over the 10.6, and then equals the sine of angle B, and I'm going to call that my x, but you could absolutely leave a capital B there, and then over little b, 9.7. So as a little note, if I have anybody out there that tends to write all in lowercase or tends to write all in capitals, stop it. You're going to confuse the heck out of yourself. All right. So you got to be really specific with this. All right. I still want you to start by cross multiplying because we're trying to get the x part of it alone. So go ahead and start by cross multiplying here. We get 10.6 times the sine of x. Cross multiply this, I would get 9.7 times the sine of 42. Right? You can't divide the sine out, but we could at least divide the 10.6 from both sides. That's going to leave me with sine of x equals this big old conglomerate right here. I'm just going to write it down one more time. All right. Once you get to this step, this is where we use the inverse sine, because the only way to undo sine here is to now say, let's do sine with that little -1 power. That's inverse sine of this right here. I'm going to be a little lazy. I'm not going to write it down one more time. So on your calculator, if you want to keep everything exact, then what I would suggest, oops, let me get that out of the way there. Got a little glare happening here, is I would do second sine and then do my alpha y equals. You could absolutely get this decimal first and then do inverse sine of your answer. That's fine, but that's just depends on how comfortable you are with those steps on your calculator. Okay? So please make sure, if you don't happen to have your calculator right now, you're going to be on your own then trying it for the first time when you do the homework. So make sure you understand how to do this. So inverse sine of that whole thing, and enter, we should be coming out with 37.75, and it keeps on going. So the angle measure to the nearest degree, then we're looking at about 38 degrees here. Any questions on that one? Okay. We might not have enough time to fully finish it, but I want you to at least try one last one to make sure we've got the setup. So number 6 is the last one that I wanted to look at together. As long as we're okay with 5, we should be okay with 6. So get it set up in your diagram and then see if you can get your proportion set up over here. All right, so when we're looking at the info, this time, you guys, we've got angle A is what we're looking for. We've got baby A, and then we've got the pairing of angle C and little c. So if it's not A and B, then you're just going to use the part of the proportion that had the A and the C. So all I mean by that, just to make sure I'm clear, is sine of A over little a, and then equals sine of C, capital C, over little c. So you just use whichever parts are available to you. Right? Simple as that. So if we set this one up, it should be sine of x and then over 5.2 and then sine of angle C, so that's 47 degrees, and then over 8.4. Here's another one that because you're looking for the angle, you would cross multiply and then ultimately end up using inverse sine to get that answer. So if I show it, it'd be 8.4 times sine of x and then equals 5.2 times the sine of 47. Oops, I actually used pencil for once. So let me get that out of my way. Divide by 8.4. And then my last step would be to do the inverse sine of that whole big expression right there. So into my calculator would go little sine of the -1 and then of that whole thing. So 5.2 sine of 47 over 8.4. For time's sake, because I don't want to keep you guys too late here, if you try it on your own, what you should be coming out with is about 27 degrees. So make sure it checks out for you. You do have traditional homework tonight, so no video to watch. What you guys are going to do is when you flip the page over, homework 1 is on pages 4 and 5 of your packet. That is what you are going to complete for tonight. So you're going to see that in Google Classroom. I still want you to submit the homework so that we can talk about it tomorrow. So you've got 6 questions to try out. If you get stuck on something, write me a note. Otherwise, you're doing day 1 homework tonight, and we will go over it tomorrow in class. If you have any questions, stick around. Otherwise, I'll see you guys tomorrow.